going on, kilowatts, Mr. Power here. Let me try and explain to you real quick about what like a kilowatt hour is and how to. So you're trying to figure out like how much energy different kind of like power plants provide and wind generators provide and whatnot, and how much energy is needed through the year and all these numbers and trying to make sense of it all. Okay, so first of all, a watt. Okay, a watt is a unit of power, all right, and it's basically it's energy per second. Okay, so or in other words, energy is measured in joules, so it's a joule per second, and then a kilowatt. Okay, 1 kilowatt is just 1,000 watts. Kilo is the prefix for basically for 1,000. Right? That's just some background. You're not necessarily going to have to like be making these conversions. It's just so that whenever you see kW kilowatt, that you even know what that means. Right? So you also probably see you mostly deal with kilowatt hours. So a kilowatt hour is like how many kilowatts are consumed or used in an hour. To calculate that, it's just like the number of kilowatts either used or provided by something times the number of hours. So if you use like say let's see 0.004 kilowatt like light bulb, a little tiny thing, for 2 hours, and you'd multiply those together and that'd give you whatever that is, that many kilowatt hours, something really small. So like a solar panel, for example, okay, like a typical, I would say, residential solar panel that's about like 5 feet by 3 feet puts out about 300 watts. Okay. Has that energy like potential or capacity. That is, since there are 1,000 kilowatts in a watt, or 1,000 watts in a kilowatt, 300 watts is equal to 0.3 kilowatts. All right, I took 300 divided by 1,000 to convert it into kilowatts. So residential solar panel puts out like 0.3 kilowatts. And so to figure out how many kilowatt hours it provides like in a day, you would just take that and multiply it by 24 hours. Right? And that would be 0.3 times 24. I did the math already up here. 7.2 kilowatt hours. Right? In a day. All right. In a year, you would do 0.3 kilowatts times there are 8,760 hours in a year, and that is 2,628 kilowatt hours. Whoa. Now compare that to, that's just a single residential solar panel. Compare that to, like, I keep on using Hoover Dam as an example. The thing is massive. Like, look up Google images of it or something. Compare that to the Hoover Dam. Here's how many kilowatt hours the Hoover Dam provides in a year. Not 4,000, not 4 million, but about 4 billion kilowatt hours. But, I mean, yeah, watch some YouTube of the Hoover Dam in operation. Just look at pictures of it. I mean, it's pretty incredible. So it's not like, wow, there you go, wind is, or water's the best, hydro's the best for the win. I mean, we're talking about drastically different things, but just to give you, I guess, some sense of scale.